I am a physics teacher and mathematics. So in continuation to our previous lesson in mathematics grade 9, where we were dealing with sequences. Today we are going to deal with the next type of sequence, being the geometric sequence. So we said a geometric sequence, we get terms by multiplying a constant, or the first term by a constant. So we remember that we said this first term should not be a 0, but it cannot be a 0, because if anything multiplied by 0 will be 0. That says we will never get a sequence that has the different terms. So let's quickly go on. Remember again, we said this is the nth formula, or the general nth formula for a geometric sequence. So in this formula again, we still have an, a1, and we have the n right up there being the index. But this time around again, we now have the r. What does the r say to us? It is the common ratio. The r in the sequence is the common ratio. So moving on, in this sequence, let's see how to find a common ratio. Like we did previously, we said the n means the possession of the term. Therefore, if you are to find a common ratio, you are going to take the term at any position that you will choose. And that says if you choose position 3 or you position 5, then here at n you are going to substitute 5. Therefore, you will have term number 5 being divided by the term number 4, which is the previous term, or the term before that term. Let's have a quick example by looking, or maybe making an example with the first sequence. We have the sequence here, but if you can compare it to other previous sequences that we had, from 3 to 6 we have 3. That says if you add 3 to 6, you will 3 to 3, you will get 6. But adding 3 to 12, adding 3 to 6, you will now get something different, which is 9. Then it does not follow the pattern. That says this time around we are having a different sequence. Now we call that sequence a geometric sequence. Why are we saying it's a geometric sequence? You will realize that from the first term to the second term, if you multiply some constant, you will get, with some constant, you will get 3, you will get 6. Multiplying 3 by 2, you will get 6. You multiply 6 by 2, you will get 12. That says now maybe the sequence is to generate the terms, we are multiplying the first term by by 2 and raised to a certain to the position minus the minus 1. So from this sequence, let's first generate or calculate the common ratio. So let's just take any position. This is position 1, 2, 3, 4, and 5. Let's go for position 4, or let's this time let's go for position 5. That says we would have, when we see n being the position, we substitute the 5. Then we have a5 minus 1. This will take us to a5 over a4, where we say 5 minus 1 and we get 4. Then that says we are going to divide the 5th term with the 4th term. So the 5th term, going back to our sequence, is 48. The 4th term is 24. So dividing 48 by 24, we get 2. That says the constant that we are multiplying the first term with is 2. And being raised to the n minus 1. And says our common ratio for this specific sequence is 2. So then when you are being asked to find the nth term or the nth formula for this sequence or any sequence, remember we said you are going to go to the general formula, which is the an equals to a1 n minus 1. So from this, now we have now calculated the common ratio being our r. And remember, we said that this formula is being called the nth term or the nth formula because it is written in terms of n. So in your formula, we should see the n in that in your answer. So for this sequence, if we are asked to find the nth term for this sequence, then we will first go on by finding the common ratio, of which we have just did. So what's left for us now is to substitute. So our first term from the sequence is 3. Then we put 3. Then we put our r. Then r is, we found r as 2. That says we say multiplied by 2 raised to power n minus 1. This is our formula for the sequence. You have to note this. There is never a time that you are going to be able to multiply 3 by 2 to power n, because 2 and 3 are they have the basis. If you go to the indices, you will find that the rules of indices says that you will only be able to calculate this to work these two numbers or calculate or operate them if the bases are the same. But this time around we have 3 being raised to power 1 multiplied by 2 to n minus 1. Since we don't know the value of n, that's why we will leave our formula or nth term in a form or in this form, of which, like we said, we wanted to have the nth term in terms of n. That says it would be best if you leave your formula in terms of n. And going back to this, we are saying that you would not be able to say 3 times 2 to power n minus 1 equals to maybe 6 to power n minus 1. That would be wrong mathematically, but you will just leave it right here where we have our nth term written in terms of n. That says we have found the nth formula for this sequence. So let's go to the next example, because the geometric is a bit tricky. So for the first one we have, for the second one we have 2, 4, 8, 60. So you are now being asked to find the nth term for this particular sequence. So we said, first of all, we are going to find the common ratio being the r. Okay, let's state the general nth formula first. So we don't know the common ratio. So finding the common ratio, we will have r equals to an over an minus 1. Then going to our sequence, we have position 1, 2, 3, 4. So if we have these positions, let's go to position 2. Going to position 2, we have 2, a2 over a2 minus 1. So going to our sequence, we will see that a2, we go to position 2, then term number 2 is 4. Then we have 2 minus 1, we know that we will get 1. Then that says it's term number 1. And our term number 1 is 2 from the sequence. Then 4 divided by 2 is 2. That says for us to generate this sequence, we have the common ratio being 2. So let's go on. we were asked to find the nth term for this sequence. Then now we have to substitute in the nth formula. Then our first term from the sequence is 2 multiplied by, then our r this time around is 2 raised to power n minus 1. That says our nth formula or nth term for this sequence is an equals to 2 times n minus times 2 to the power n minus 1. Then you leave it right here because we said it should be in terms of n. So if you, and we don't know n, that says now after finding the nth formula, the nth term, we said that you would be able to calculate any term at a given position. Let's make an example. If you are asked to calculate the 15th or the 10th term of this sequence, that says where you see n, of which we said is the position, and you are told that calculate find the term at position 10, we will note it this way. So it's 2. Our first term from the sequence is 2, we know it. So, and our common ratio is also 2. It should be raised to power n minus 1. So we set our n is 10. That says we say 10 minus 1. And this would be 2 times 2. 10 minus 1 is 9. Then we would be having a 2 multiplied by 2 to power n. Again, remember, now taking that rule of indices, we are saying that we have 2, this is 2 to power 1, and this is 2 to power 9. And that would allow us to say through the rules of indices, the bases are the same. 2 and 2 being the bases are the same. You take the base and you add the index or the powers. That says it's 1 plus 9. Then we'll get 2 to power 10. Then your 10th term would be 2 to power 10. So what's left for you now, for us, is to find 2 to power 10. And that value would be our 10th term. Okay, now that we have looked into these 2 examples, this is an exercise for you to see or to assess yourself at home and see if you understood what we have been doing. Thank you.
Le gupile mmetse ha holo jwa mmetse wa grade 9 ko na ha mmetse wa grade 9 mme nka eletsa hore hona mmetseng o le o kopang ka bo di topic tsotlhe tse le di kopang o tlobe specific ka topic ye o batlang hore matitjhere a tla e otla otle ho nolofaletsa mosebetsi wa ka sekolo. Re fumane di comments tsa lona, tswelang pele nne le subscribe le fane ka di comments e le hore re tsebe ho tlisa seo le se hlokang ka tlung.